Good afternoon, everyone. Today we will explain Newton's method, section 4.8. So let's start. Please write your name and student ID for attendance, okay? And you need to participate, okay? So, let's start. Okay. First, I want to ask you, when you want to solve a quadratic equation, for example, ax squared plus bx plus c equals 0, how to solve this? We have formula, right? We have the formula x equals we have the formula x equals minus b plus or minus square root of b squared minus 4ac, here b squared minus 4ac over 2a. So we have formula for quadratics, right? What about cubic? Next we have degree 3. Do you have formula for degree 3? Yes, we have. I will show you. See here. So let's see. So first we have quadratic formula, this one, right? What about the cubic? We have this formula. It's complicated, right? Would you use this formula? What do you think? This formula is very complicated. It's not good, right? The one for cubic, see? So it's not easy to solve the cubics, even though you have formula here. But what's the problem with this formula? It's very complicated, and sometimes you may have integer solution, but it's in a very complicated form and you don't know. For example, you may have cube root of this plus cube root of this minus this equals 1, for example, but you don't know that it equals 1, and it's hard to prove it equals 1 because this is very complicated. So this formula is not good, right? Even if you use computers to compute this, it's still not good enough. So we need to find better ways to solve equations, right? What about degree 4? Do we have formula for degree 4? See here, this is degree 4. Yes, we have formula. This is, yes, this is the formula. Would you like to use such formula?
No.
It's very complicated, right? And it's not useful. It's useless. So, what about degree 5? Fortunately, we don't have formula for degree 5. Fortunately, because if it exists, it would be complicated and useless. But it does not exist. So this about polynomials. What about other equations? For example, what about e to x equals x squared plus 5 plus cosine x? Do you have formula for the solution of this equation? Clearly no, right? What about x equals cosine x? No, we don't have. So, we need to find the efficient method to solve equations, right? Because we don't have for degree 3 good way, I mean easy way, we don't have easy way for degree 3, degree 4, or these equations, e to x equals this, x equals cosine x. So this is the idea about Newton's method. It's easy way to solve equations. Now let's explain Newton's method. So let's go. let's go here. We'll start explaining Newton's method now. This is very important, okay? So let's explain this graph first. See this graph. See the blue one, f of x. Here, this is f of x, okay? We want to solve the equation f of x equals r. I mean 0. f of x equals 0. From the graph, what's the solution of this? It's r, right? So x equals r. So x equals r is a solution, right? Now here x equals, let's continue. Let me
Trigonometry.
let me repeat again to make it clear. Yes. So x equals r. From the graph we see that x equals r is a solution, right? And you can use graphing to estimate the solution, but assume the graph is hard to draw. How to approximate the solution? Let's see here. First, you choose initial point x1, okay? Here x1, okay? Then you find the tangent line at x1. Then the tangent line intersects the x-axis at x2, okay? Which x value is closer to r, x1 or x2? What do you think? Here you have x1, here x2. Which one is closer to r? x2, right? I mean, yes, x2. So x2 is closer. And now, again, draw the tangent for this. You get, here you get x3. So you see, using tangents, you are making good approximations of the solution, right? Again, it will be, yes, something like this. So here x3, here x4. You keep getting closer to the solution. Are you good with this?
Yes.
Okay. Now let's explain the formula. So now this is the general idea, but now how to write formula for this? First, you find the equation of the tangent, okay? What's the equation of the tangent? Y minus fx1, because remember we started with the x1. So y minus fx1 equals f prime x1 x minus x1. So we have this equation. Now you want to find the intersection, the x-intercept of this line. How to do it? You can do it by substituting y equals 0, right? X equals x2, because this is the x-intercept. We know that x2 is the value, okay? So we have what now? We have 0 minus fx1 equals f prime x1 x2 minus x1. We need the value x2, so we solve the equation for x2, okay? Divide both sides by f prime x1. You get minus fx1 over f prime x1 equals x2 minus x1. Add x1 both sides, you get x2 equals x1 minus fx1 over f prime x1. Do you understand this formula?
Yes.
Yes.
Okay, but here there is something important that we need to say. Can we divide by f prime x1? We need to assume what? We need to assume that f prime x1 is not 0, right? because if it's 0 then Newton's method will not work. So for Newton's method to work, you need the derivative to be non-zero at the x values, x1, x2, these values, to get a good approximation. It's not good to have the derivative equal 0 because the method will not work. See here, we divided by the derivative. If the derivative is 0, then it will not work. So remember this. F prime x1 is not 0. Now if you apply the same step for x2, you will get x3 equals x2 minus f of x2 over f prime of x2. Now if you apply it to x3, you get x4 equals x3 minus fx3 over f prime x3. And again, you want the derivative to be non-zero. So f prime x2 is not 0, f prime x3 is not 0. Now, in general, what's the formula in general? xn plus 1 equals xn minus fxn over f prime xn. So this is the general formula. The whole section, I mean Newton's method, is just about this formula. So we will start solving equations using this formula. But before that, let's get back here. So here we have the explanation. See here it's better than my drawing. See here, you start with x1, then the x-intercept of the tangent is x2. It's getting closer to r. Then again, draw the tangent line for x2. You get the x-intercept is x3. It's closer to r. See x4. x4 is very close to r, right? See here, it tells you that you need the derivative to be non-zero for all n, for all n values, because the method will not work if the derivative is 0. See, you can understand it. It's not hard. For example, you know that when you divide by number, you need it to be non-zero. So this is easy, right? Now let's go, and here it tells you that limit of these values x ends as n goes to infinity, it will be exactly r. So if you keep calculating more x ends, you will get r, exactly r. But here there is something important. Sometimes the method will not work. For example, see this curve. But don't worry. When we give you example or problem to solve, we'll give you a problem that the method will work for it. But this for understanding here. See here. So here we want the value r. Okay. So start at x1, draw the tangent line. You get x2. Is x2 closer to r? x2 is not closer to r. It's away from r, right? So, and then try to draw the tangent line for x2. See here the problem, x3 is even out of the domain of the function. So here x3, you even can't apply the method again, because x3 it's not in the domain of the function. See, the function is just here. x3 is out, it's negative number, it's out of the domain of the function. So the method will not work for this. So this is the idea, that sometimes the method will not work. But how to make sure that it will work? You choose x1 to be close enough to r. What do you want to say now? You may get angry now and you say, how do you want us to choose x1 to be close to r even though we don't know r? You may want to say this, right? That we don't know the value of r, so how you tell us to choose x1 to be close enough to r? I will tell you how to do it. I mean, there is a way to know where is the solution and how to choose the x1 close to it. And the way you know it, you studied it in the end of chapter 2, the intermediate value theorem. Intermediate value theorem, yes. So I will show you later with example how to choose x1. But sometimes x1 is given. But why sometimes the method will not work? See here. Here you have explanation why sometimes it's not working. Because sometimes f prime x1 is close to 0. I will show you. For example, if you have f prime x1, for example, equals 0.01, then 1 over f prime x1 equals what? Equals 100, right? So this is a problem, right? So for example, if I want to find x2, assume x1 is for example 3. So if I want to find x2, for example, x2 equals what? Equals x1 equals 3 minus f x1 over f prime x1. But 1 over f prime x1 is what? Is 100, right? So times 100 here. Assume if x1 is, for example, 2, then 2 times 100, 200, so you get minus 197. See? So this is the idea. Sometimes the method will not work if the derivative is very close to 0. This is just for understanding. I mean, you will not have these problems in the problems that we will solve. Now, let's solve the example now. Do you have questions? Please remember, all of you, to write your names and student ID. Now, let's solve this example. So here x1 is given. You need to solve as I am writing now, okay? So first, write the formula. And before the formula, write the function f of x equals x cubed. So f of x equals x cubed. Then what's the derivative here? F prime of x equals 3x. It's not just x cubed. We have also minus 2x minus 5. So minus 2x minus 5. Then what's the derivative? F prime of x equals 3x squared minus 2, right? Now you write the formula. You have xn plus 1 equals xn minus f of xn over f prime xn. Then this equals, now you substitute xn in f and f prime. You get xn minus xn cubed minus 2xn minus 5 over what? Over the derivative. You substitute xn. You get 3xn squared minus 2. Good? Now you have x1. x1 is 2. Next, you find x2. See? Write the formula once and then you use your calculator to find the values. So x2 equals what? Let's see. We will use calculator now. So let's see. First you substitute x2. I mean x1 equals 2. You substitute in the formula. See, like this. So you start 2 minus, then you open, so 2 minus, you open parentheses for the numerator, okay? You get 2 cubed minus 2 times 2 minus 5. You close the parentheses, okay? Then you divide by You open parentheses now for the denominator. You get 3 times 2 squared minus 2. You close it, and now you click enter, you find the result. It's 2.1. Okay, so x2 equals 2.1. So you apply the formula without writing here x2, without writing x1 minus x1 cubed minus. You write it once like this, you write it like this, then you apply using your calculator. This one tells you to find x3, so let's find x3 now. So x3 equals, here when you use your calculator, you don't keep writing 2.1 now when you want to find x3. I click Control C and Control V, okay? And using your calculator, you can use this button, answer. You can use answer to, for example, when you found x2, right? So here you using your calculator, you do like this: answer minus answer cubed minus 2 times answer minus 5 over 3, and you keep doing this for the next values. So after finding x3, if you want to find x4, you use answer, so you don't need to write a lot of digits, right? So use this, but I will use Control C and Control V, okay? So let's start. So we have x3. So let's start. You have 2.1 minus 2.1 cubed minus 2 times 2.1 minus 5, then close the parentheses, then divide, open a new parenthesis now, 3 times 2.1 squared minus 2, close the parentheses, and now you get the final result. You get 2.094568. Don't write just like this 2.0, write some digits, okay? For example, write 6 or 7 digits. Are you good with this? Do you have questions? Is it good?
Yeah, Professor.
Yes.
Can you go back for 1 second?
Yes. Yes.
Yeah, so how did you know to make the formula xn plus 1 equals xn minus 1 over f x over, yeah, this formula, how did you know to make it like this?
We explained that a few minutes ago. You, I will show you again. First you choose x1, okay? Then you draw tangent line. Then you find the intersection with the x-axis. You get x2. Our goal to find r. R is the solution that we want. Choose with, see here. You start with x1, but see x2, the intersection of the tangent with the x-axis. X2 is closer to r, right? And if you keep repeating this, see here, here, find the tangent for x2, then the x-intercept is x3. See, x3 is closer to r. But what's the formula for this? The formula, you find it like this. First you find the equation of the tangent, then you substitute the y is 0 and x is x2, the x-intercept So you substitute x2 0, then you solve the equation, you get the formula x2 equals x1 minus fx1 over f prime x1. And now if you repeat the same step with x2, you get x3 equals x2 minus fx2 over f prime x2. So in general you have this formula. Are you good with this?
Yes, thank you.
You're welcome. Now, do you have another questions? Okay, let's solve another example. Please, if you have any questions, please ask me. Yes, this one is important here. The sixth root of 2. Here we have a new idea, but it's easy. It's not hard. So use Newton's method to find the sixth root of 2 correct to 8 decimal places. But now I want to ask you. You don't see the function here, right? So how to build the function? This is the new idea here. And you also need to choose x1. Let me show you again. Let me show you how to find the function. You write x equals sixth root of 2, okay? So sixth root of 2. Then you raise both sides to sixth power, you get x to 6 equals 2, right? Subtract 2 both sides, you get x to 6 minus 2 equals 0. So our function is f of x equals x to 6 minus 2. Are you good with this? So this is how you find the function when it's not given. You write x equals the root, then you try to solve like this. Then you get the function. Now what's the derivative? F prime of x equals what? 6x to 5, right? And you write the formula. xn plus 1 equals xn minus f of xn over f prime xn equals xn minus xn to 6 over 6xn to 5, right? Now we need to choose x1, right? Because x1 is not given here. Now we need to use the intermediate value theorem. But before that, we need to find this equals to 0, right? How to estimate x1? I told you before that you need to choose x1 to be close to the solution, right? You use intermediate value theorem. This function is continuous, right? Continuous. So now, if I want to prove, if I want to estimate the solution, or to know nearly where is the solution, I can use intermediate value theorem, right? So see here, 0 greater than what? Than f of 1 equals what? f1 equals minus 1, right? And 0 is less than f of 2 equals 2 to 6 minus 2, which is 62. Clearly positive, right? Here positive, here negative, right? So we know that there exists solution between 1 and 2. So we know that sixth root of 2 belongs to what? 1, 2. See here, here is 1 and here is 2. So the solution such that f of x equals 0 is between 1 and 2. So which value you will choose for x1? 2 is not good. See, you get, if you substitute 2, it's away from the solution. You get 62, the answer. But if you substitute 1, minus 1 is close to 0, is closer to 0 more than 62, right? So it's good to choose x1 equals 1, right? But if you choose it to be 1.5, also it's also good, or 1.2 or 1.3. So you choose something between 1 and 2. You can choose 1 if you want, you can choose 2 if you want. But the idea, you need to choose it to be close enough to the solution. Here you know that it's close enough, 1 is close enough. Why? Because if 1 equals minus 1, it's very close to 0, right? Do you have questions about this? Here I will choose x1 equals 1, okay? So let's solve now. Here the other idea that we will need, we want to estimate it correct to 8 decimal places, right? I will show you while we solve. I will show you how to know whether it's accurate to 8 decimal places or not. So x2 equals what? You apply this formula, okay? You substitute x1 in this formula. Let's start. So x1 equals 1. You get 1 minus, you open parentheses now, 1 power 6, it's just 1, right? Divided by 6 times 1, just 6. Here we have, here you must have what? X into 6 minus 2, right? So let's do it again. You have 1 minus, you open parentheses, then 1 power 6 is 1, minus 2, close the parentheses, then divide, open parentheses, 6 times what? Times 1, right? You get 1.16 repeating. So you write it like this, 1.16 repeating. Remember, this here is the function if x is x to 6 minus 2, but I forgot the minus 2 before, but I added it now. It's here, minus 2, okay? Now you apply again. Let me write them again, but here remember this is minus 2. So x2 equals 1.16 repeating. Now let's find x3. x3 equals x2 minus x2 power 6 minus 2 over 6 x2 power 5. Now control C. You can use answer if you are using your calculator. You can use answer. Also try with me to see whether my solution is correct. I mean, you practice and you check with me. So control C. Let's just start again. Control V minus, open parentheses, control V power 6 minus 2, you close the parentheses, then divide, open parentheses, 6 times control V power 5, close the parentheses, you get 1.126443. Write 8 digits because the question tells you to find correct to 6 digits. So I will also add 6, 7, okay? Now, how to know which digits are correct? I will show you. Here you have 1, here you have 1, right? So you know that this one is correct, because each time the solution gets closer to the value. So if you have 1 in both of them, then 1 is correct. Now next, see x2 and x3. You have 1.1, you have 1.1. So you know that 1.1 is correct. 6, it's not correct, because here you have 2, not 6. And 2, we are not sure yet whether 2 is correct, because we need to find more. When you find x4, you will see. Let's find x4. x4 now. So now control C. We start the same steps again. Control V minus, control V power 6 minus 2, close the parentheses, divide, open the parentheses, 6 times control V power 5. You get this. Yes. No, again. Yes, it's correct. So now, which digits are correct here? What do you think?
1.12 is correct.
Yes, thank you. So these are correct. These two we are not sure yet. We need to find more to see whether this two is correct or not. Now let's find x5. And the important thing that if you want, you can do some trick to know which digits are correct, right? What's the trick? What do you think? You can find the exact value of this using your calculator and see the correct digits, right? But don't do this because you need to understand the idea that, for example, here 1.12, here 1.12, so you know they are correct. So assume that you don't know how to find sixth root using calculator, okay? Just depend on Newton's method to practice. Now x5. So control V minus, open parentheses now, control V power 6 minus 2, close the parentheses, then divide by, open parentheses, 6 times control V power 5, close the parentheses, you get this. Now we know this is correct up to here, right? 1, 2, 2, 4. Let's find x6 now. x6 equals, now control C, control V minus, open parentheses, control V power 6 minus 2, close it, then divide, open parentheses, 6 times control V power 5, close it, you get this. We are nearly done, right? Because till now you have 7. The book will approximate this to 5 and stop here. But I don't want to estimate because I want exactly 8 correct without estimating. So we need step x7 now. So x7 will be the last one, okay? So x7 equals, let's find x7 now. So control C, then now control V minus control V power 6 minus 2, then divide 6 times control V power 5, close, yes. Now we have 8 correct decimal places, right? Because they are the same. We want just correct to 8 decimal places, so we stop here at x7. If you want correct to more digits, you find x8, x9, as you like. You decide how much you want. But now let's find the exact result using calculator to see that these are really correct. So 2 power 1 divided by 6. See? 1.12246204. So it's correct. Even if I write more digits, it was correct when I found this one, x7. I think we had also 8, but I didn't write it because we want just to 8 decimal places. Are you good with this? Do you have questions?
Professor, how do you find x1 again?
Yes, x1 again. Now, for x1, you use the intermediate value theorem. Remember, the intermediate value theorem tells you what? That if n is greater than fx, let's write it clearly. For example, f of a less than or equal to f of b. Okay? And f is continuous. Okay? Then there is r in open interval AB. Make it less than if you want. If it's not less than, you write it closed here. Okay, so it works. Now there is r belongs to AB such what f of r equals capital N. So this is the idea. X1, let's explain how to find x1 for this function now. See our function, I want to solve this equation, x to 6 minus 2 equals 0. So our n, my n in this problem is 0, right? So 0 greater than something, less than something. What is less than 0? Negative numbers, right? So I want to find here I want to find negative number. I mean x value such that f equals negative, which is f1. F at 1 equals what? 1 to 6 minus 2. 1 minus 2 is minus 1, right? Then here, the other one. Substitute 2, for example. F of 2. F of 2 equals what? 2 to 6 minus 2. You get 62. So, you know that there exists r such that f of r equals 0. And we know that r equals what? 6th root of 2. But before that, how to find x1? x1 will be between a and b. What are a and b? 1 and 2, right? Now, using Newton's method, you want to find the closer, to choose the x value that is closer to the solution. Which one is closer to the solution? If you substitute 2, you get 62. It's very away from 0, right? If you substitute 1, you get minus 1. Minus 1 is closer to 0, right? So it's better to choose 1, right? What do you think?
Yes.
So this is the idea. You use the intermediate value theorem to estimate the value. And not only one will work. For example, if you choose 1.2, it will be better, right? Not necessarily better, but it's also good. It's also good because you have the exact value is nearly this, right? So if you choose something close to this, it will work. You can choose 1. I chose 1 because 1 is integer, is easier, right? So this is the idea. Do you have another questions?
No, thank you.
You are welcome. Now, next we have the cosine example, I think. Yes, the cosine example. You can estimate x1 using graphing, okay? If you want, you decide. I will show you this example. For example, the book estimated x1 using graphing. You have y axis here, you have x axis here. You draw cosine. Here you have 1. Here you have pi over 2. It will look like this, right? And you also continue it here if you want. This is cosine x. You also draw the y equals x. See here you have cosine, here you have x. You graph both of them to estimate the solution. This is y equals x. Remember, pi over 2 equals what? Nearly 1.57. Nearly 1.57. What's your estimate for this value here? What do you think? Nearly, what's the solution? Using a graphing, what do you think? Do you hear me? Do you hear me?
Yeah.
What do you think? Approximately, what's the solution for this? The x value, I mean. What's your estimate for this?
Pi over 4.
Not necessarily pi over 4. Choose number, I mean. Tell me the digits, not in terms of pi.
I don't know.
For example, x equals 1. X equals 1 is closed, right? Because 1 less than 1.57, right?
Yeah, maybe.
It will be something between 0 and 1.57. So here nearly 1 is good. 1 or a little bit less than 1. So if I choose x1 equals 1, it's good, right? This is one way to estimate x1. To choose x1. If you don't want to draw the graph, there is another method using intermediate value theorem again. So here, solve this equation. You get x minus cosine x equals 0, right? So our function is f of x equals x minus cosine x. I want this to be equal to 0. Using mean value theorem, not mean value, intermediate value theorem. You want to find if n greater than equal to f of a less than equal to f of b. In our example, n is 0, okay? So I want to find a value such that f of a equals something negative, okay? Here less than, okay? Less than. So, for example, if I choose f of 1, no, I should start with 0, f of 0 equals what? 0 minus cosine 0. What is cosine 0? Minus 1, right? Minus cosine 0, with the minus it's minus 1. So minus 1. It's negative, right? So 0 is good. Now f of b, for example, choose f of what? F of pi over 2, for example. You get what? Pi over 2 minus cosine pi over 2. Cosine pi over 2 is 0. So you get pi over 2, which is nearly 1.57. So the same idea with the graph. You can do it like this, using the intermediate value theorem like this. So as you like, you draw the graph of this function cosine x and x. Then you estimate the value using the graph, or use intermediate value theorem. Which method is easier for you? What do you think? What's your opinion? Do you like the intermediate value theorem, or using graphing each function then estimate the solution?
Intermediate value theorem?
Yes. Me, I prefer the intermediate value theorem, because sometimes you may have a function that you cannot draw the graph, right? So it's easier to use the intermediate value theorem. And if you want, you can also approximate it. You can also not pi over 2. You can, if you want, use f1, for example. It will be also positive answer. So the solution is between 0 and 1. So if you want, you can make it better choice for x1. But x1 equals 1 is good. But let's stop here. We will solve this example again next time. Your exam next week, right?
Yeah, it's on Thursday.
Yeah.
Not the one after.
Make sure to watch the mean value theorem videos. I uploaded another video other than the one that the audio was not good. So I will show you again. See here. Here is better video. So this one for the first part of mean value theorem. Then here for the second part, last week, this one. Today I will upload the Newton's method, but it's not in in this exam, right? It will be in the final, right?
No, what section is it?
4.8. Newton's method is 4.8.
No, it's not in this midterm.
Yeah. So it's just mean value theorem. I hope you do the best. Go for the full mark. Now you can leave if you want. I will take the names, and have a nice day.
Thank you. Have a good day.
You are welcome.